Hello everyone, welcome to Graph It Out. In today's session, we are going to look at the proof that gives an expression for cos x plus y in terms of cos and sine of x and y. Now, you need to know that I haven't touched some of these topics in like really long time. So it's very easy for me to make a few mistakes here or there. And if I notice a few mistakes after making the video, I will put a note either in the video description or in the pinned comments. Please look for that. Now, if you notice some mistakes, please report that in the comment section. This is expected of you, and I will be very thankful if you do that. Before we get to the proof, let me show you something. I have a graph and a few slides prepared for this session, and you can get that from this particular repository. Now, you don't have to type the entire URL. I will provide a link to it in the video description. And once you are in this repository, look for this main readme.md file, and there all the links are available there. So today's proof is cos x plus y proof 1. And I have that graph open here. So this is the graph that you will see. This is like the skeleton of the proof. So let's start from the top. These are the dependencies for the proof. That means you need to know these ideas before you can proceed to the proof. And these are very basic ideas, so you probably know most of it already. Let's start from here. So sine, cos, etc. Of course, today's session is all about sine and cos. And if you are watching this video, you probably already know that. Euclidean distance. Okay, let's click that. So this is the, let's say that I have 2 points in a 2D plane. What is the distance between them? There's an equation for that. This comes directly from the Pythagoras theorem. It's nothing too complicated. It's a very basic result. Next we have the SAS theorem. This is the side angle side theorem. So imagine that we have two triangles, and we want to know if the two triangles are congruent. What do we mean by congruent? Let's say I take one of those triangles and try to place it on the top of the other. And if, after some rotation and flipping, and if I can get those to be exactly matching, that means all the three sides are matching between the two triangles and all the three angles are matching. In that case, we can say that those two triangles are congruent. Now, here's the thing, that there is a lot of redundancy in a triangle. That means we don't have to actually check three sides and three angles. Now, the side angle side theorem is one way to check whether those two are congruent. So as per side angle side theorem, you just have to check two sides and the angles between them, between these two triangles. So in this case, AB is equal to PQ and AC equal to QR. And the angle between these two, here it's alpha and here it's beta, and these three are matching between these two triangles. So we can say that these two triangles ABC and QPR are congruent. This is a very basic result. I will not go into the discussion of that. You can find this result in any of the textbooks on elementary geometry. For most people this is obvious, but if you want proof, you will have to jump into some textbook. Now let's start the proof. Before we start, okay, what exactly are we going to prove? We want to find an expression for cos x plus y in terms of cos x, cos y, sin x and sin y. So cosine of sum of angles in terms of cosine and sine of individual angles. Now this is I would say it's a very important proof. It's a very important result. We will be building quite a lot of results on the top of this. So you might want to really pay attention to what we do today. So that's the starting point of the proof, and this is the structure of the proof. So first we will look at the chord length with single angle. I'm sorry, with a single angle, and then we will look at the chord length in case of two angles, and then Based on that, we construct a diagram which has two angles, and then we compare the chord lengths between those two to get the final result. So that's the general structure of the proof. Now let's go one by one and see where we get. So let's start with one angle, that is x here, and B is the point that corresponds to the angle x. A corresponds to angle 0. So now let's try to find the distance between A and B. For that we have to find the coordinates of A and B, which you can find here. Notice that the circle is a unit circle. That means we don't have to worry about radius. Radius is 1. That's why B is cos x and sin x. Now we are going to find the length square, because for the proof we don't actually need the length, we only need the length square. And here you can see that there is a cos x minus 1 term here, cos x minus 1 whole square, plus sin x minus 0, sin x minus 0 whole square. If you expand this one, you get cos square x minus 2 cos x plus 1. And if you expand this, there's nothing to expand, it's just sin square x. And this cos square x and sin square x add up to 1, and which gets added with this one sitting here, and we get 2. And this minus 2 cos x does not, it just comes out as it is. So we get 2 minus 2 cos x. So 1 0 and cos x sin x, and we get this expression for distance square. So distance square has no sin x in it. So notice that even though we started with a sin x sitting here, at the end the expression for distance square did not have a sin x in it. So remember this expression. So if this is y, we will see 2 minus 2 cos y here. If it is alpha plus beta plus gamma, we will see 2 minus 2 cos alpha plus beta plus gamma. Whatever x here is whatever x here. Now, this is on a side note, this is not part of the proof. So we could drop a perpendicular from origin to this AB, and it will cut this AB into two equal pieces. And based on that, we can see that one of the half is just sine x by 2, I believe, and then the total length would be something like 2 sine x by 2 or something. I could be wrong, just do the basic calculation and you will get the result. That's what I have mentioned here, but it's not part of the proof. So we had one angle and we got the result. Now let's go for two angles. So with with x we had this point B, and now with y we have this point C here. Now we are trying to find the distance square between these two. So BC square. And you can see the coordinates over here, 0, 0 for origin, 1, 0 cos x sin x and cos y sin y. So the distance square would be cos x minus cos y the whole square plus sin x minus sin y the whole square. And if you expand it, you get this term from this one, and this term will give this one here. And the cos square x and the sin square will add up to 1, and cos square y and sin square y will add to 1. Then 1 plus 1 will give 2. That's the 2 sitting here. And these two idiots don't add up to anything, so minus 2 cos x cos y plus sin x sin y. That's the term here. So the expression when we had two angles, cos x sin x and cos y sin y, these 2 points is of this form: 2 minus 2 cos x cos y plus sin x sin y. Now here's the thing, what would happen if this y was negative? For example, if the C was not here but over somewhere here. In that case, this would be cos minus y and sin minus y. Cos minus y is cos y itself, sin minus y would be minus sin y. And if you do the exact calculation here, it's just replacing x with x and y with minus y, then you see that this term will remain exactly as it is, cos x cos y. This would be sin x sin minus y, and this minus sin minus y is minus sin y, so that minus will come and sit here. So instead of this plus, we will get minus if the C was sitting somewhere here. So that's the insight we need to have from this particular slide, and remember this expression because we are going to use it in the next slide. So based on the insights from these two cases, we are going to build the diagram for the proof. So let's start with the angle X is sitting here, that is angle AOB is X. And now for Y we have two options, either we can put Y on this side or on the other side. So if we put it on here, that is BOC is angle Y, and if you put on the other direction, AOD is minus Y because it's going to the negative direction. So this total angle is X plus Y, and this total angle is also X plus Y. Why is that? Because X minus Y would be X plus Y. That's how this is X plus Y. Now we can see that this length and this length are same. This length and this length are same, and the angles between them are also same. So triangle AOC and triangle BOD are congruent, which means this red AC and this green BD are both same. If the lengths are same, then the length squares are also same. Now this AC, this point is 1, 0, and this triangle is similar to the case that we saw before. Here there was only a single angle. Here it was X, but in the case of the main diagram it is X plus Y. So this red ones correspond to the single angle case. And in terms of BD, the B has cos X, sin X in it, and D has cos Y and sin minus Y in it, or minus sin Y in it. So this is the two angle case. So when we compute BD, we have to use this result, where both points have angle terms in it. So now let's do the length calculation. So the AC square would be, again, we are not doing the length, we are doing the length square. AC square is 2 minus 2 cos X plus Y. Why is that? Because this angle is X plus Y. That's why X plus Y is sitting here. And BD square is 2 minus 2 cos X cos Y minus sin X sin Y. If this D was sitting here and if this angle was plus Y, then this would have been cos X cos Y plus sin X sin Y, like we have seen here. But since Y is sitting on the other side, we got this term to be minus. So if we compare these two sides, so we know that these two are same based on the fact that these two are congruent triangles and the length squares are same. So now we can say that these two sides are same, these two terms are same, and if we subtract 2 from both sides and divide by minus 2, then we get this expression. This is the final expression. Cos X plus Y equal to cos X cos Y minus sin X sin Y. Yeah, that's the result. So whenever we see a minus in our result, we should always check where it came from. So this minus came from here, which came from the coordinates of D, which is sitting here, and that came from this minus Y sitting here. And this term came from the single angle case, which is this one, and this term came from the double angle case. The entire thing was possible because in the case of single angle case, the sin X term disappeared because it was a square and it added up with the cos square X, and it gave us 1. So since the sin term disappeared, we were able to use this method to get a relationship between cos X plus Y and these terms. So that's the story behind this proof. Actually, you can just start with this diagram and give the proof, but then you will not have any insight. You will not understand what each term means here. The story behind the proof will not be complete if you directly start with this diagram. Try it out and let me know what is going on. Try it out and let me know how it turns out. Yeah. Bye.